And our next speaker is one of my favorites as he's doubling up again. Last year there was a sick presenter and he hopped in as the Jolly Joker of craft. And this year the same thing happened. So we have our presenter from Bristol, UK. Kevlin Henney is an independent consultant, speaker, writer, and trainer. His development interests are in programming, practice, and people. He has been a columnist for a number of magazines and sites, has contributed to both open and closed source software, sometimes unintentionally, and has been on far too many committees. He is co-author of Pattern Language for Distributed Computing and On Patterns and Patterns Languages, 2 volumes in the Pattern-Oriented Software Architecture series. He's also editor of 97 Things Every Programmer Should Know and co-editor of 97 Things Every Java Programmer Should Know. When I asked him the question that what would be the advice for the young development generation, he said, look to the past. So please welcome on stage with his speech, Kevlin Henney, Program with Guts.
Yay. Thank you. Yeah, we moved this talk back 5 minutes, so I can now say good afternoon. I was asked to give a kind of last-minute talk, and I thought, what am I going to talk about? I've spent the last 2 days doing a workshop on architecture, so I thought maybe I won't do architecture. I've got a nice talk this afternoon on technical neglect, which kind of touches on a few architectural and development process aspects. So I thought what I could really do with at this point is a whole load of curly brackets, and let's actually get into the code. So that's what I'm going to talk about, program with guts, good unit tests. So this is a very much condensed talk, so there's a whole lot of stuff that I'm not going to be talking about, which fortunately is being addressed by other talks. Did anybody just go to J.B. Rainsberger's talk? Okay, well done. You are now on the testing track. There wasn't a testing track before this morning, but there is now. This is the second talk in that. So he's talked about a whole load of stuff to do with relationships between tests and code and all the rest of it. Great. This afternoon, Ian Cooper is talking about TDD. And it's just like, okay, that's your workflow thing. So at this point, I'm right in the middle. Go, let's actually talk about the detail. Now, there's a lot of ideas here that you will be able to lift any other kinds of test. Lots of, they're not unique to unit tests, but I'm focusing on unit tests. I'm not focusing on anything that deals with dependency. A sense of moving away from the classic view that what we are doing when we are testing is simply testing for correctness, whatever we mean by correctness. These days, thanks to social media fragmentation, I am fragmented across social media. You can find me in lots of places. Very easy to find me. I have an internet unique name. So you can generally find me. I hang out a little bit on all of these places. Now, as mentioned in the intro, I'm a co-editor of this book, 97 Things Every Java Programmer Should Know. Trisha G and I finished the editing during the first wave of lockdowns, because what else were we going to do? So technically this book is 2020. We actually had the official or the unofficial launch event a few weeks ago, 4 years late. But, you know, it's software, so we're all good with late delivery, yeah? But one of the pieces that I have in this, we have many contributors to this, 73 contributors to this, and each of the editors certainly contributed. One of the pieces I have here is called Program with Guts. Uncanny coincidence, exactly the same title as this talk. Could it be that this is what we're going to talk about? Yeah, so you're writing unit tests. Great. Yeah, I mean, I'm not going to check that you're writing unit tests. You can just say, yes, I am. Okay? You know people who don't write unit tests, yeah? Of course. Are they any good? That's the interesting question. We often focus on things. People say, oh, yeah, we're doing this. Yeah, but are you doing it well or not? Because if you're not doing it, if you don't have good tests, then, well, isn't that going to cause a problem? Do you have guts? Where does this phrase come from? It comes originally from Alistair Cockburn. So Alistair Cockburn, he is one of the original signatories to the Agile Manifesto. He is the originator of hexagonal architecture, ports and adapters architecture, both of those terms. And he's been involved for a number of decades in really trying to understand the relationship between us and our software systems. And this came out of a kind of conversation that he had a few years ago. And he had this one blog, and it was an observation. Very many people say TDD when they really mean, I have good unit tests, I have guts. Because often we need a word that we can put on our CV or a word that we can talk about. And it turns out that there are many teams who struggle to express what they're doing now that is different to what they were doing a few years ago, or to do it in a way that sounds really interesting. Yeah, compared to 5 years ago, we're writing lots of tests. Oh, compared to 5 years ago, our tests are much better than they were. That doesn't sound particularly sexy. So what's the jargon? What's the alphabet soup in this space? TDD, yeah, we're doing TDD. Many of the teams that I've done workshops with or visited, and they say, oh, we're doing TDD, they're not doing TDD. But they are doing more testing and better testing than they were. They just don't have a word for it. So let's use this word guts. Guts is the thing you produce. It's not the way you produce it. TDD is a workflow. It is the way that you do something. I'm very interested in TDD. I strongly advocate its use, as well as a number of other workflows. But that's not what we're going to talk about here. I want to talk about what do you produce. When the next person comes along and looks at that code, what do they see? Do they see TDD, or do they see good unit tests? You don't see the way that something was done. Well, I say that a little bit, but actually I can normally tell whether or not somebody's been doing TDD. It's just like, yeah, you missed a whole bunch of cases. You're not TDDing. Normally it's actually quite easy, but let's just say we're focusing on guts. And you can produce guts whichever workflow that you are working with, whether you're writing your test retrospectively or ahead of the moment that you're actually implementing the functionality. So I want to focus on the artifact, the what, not the how. So have you landed someone, future you? Remember, whenever we sort of say other people is you as well in the future. And in the past, you get to blame yourself for all that legacy code you're frustrated with today. Yeah? Oh, which idiot wrote this? Oh, unbelievable, they got the same name as me. Have you landed someone else, future you, with interest accumulating technical debt in their test base? That's the question we want to ask. Which leads to the next question, what do I mean by good? We need to be concrete about this. The word good often hides a lot of things, okay? We need to be careful. We need to understand that good is a shorthand. Good is something you need to double-click on to find out what somebody means. Because otherwise you have some really meaningless conversations. Okay, I want you to imagine, here we are, we're in a meeting room, we're about to start a greenfield project. All the choices are open to us. Isn't this fantastic? And somebody says, what kind of architecture should we have? And you go, we should have a good architecture. That is an excellent suggestion. Brilliant. Okay, what kind of code quality should we have? Somebody else says, we should have good code quality. This meeting is going so well. What about our tests? Oh, they should be good. I think we're pretty much done here, aren't we? We haven't actually said anything, and everybody's nodding their heads. So you've got to watch out. Whenever anybody says, yeah, this is good, yeah. I don't know what you mean by that. Double click. Let's find out concretely what this means. Because I've had conversations with people, yeah, this is good. And then I've looked at it and go, oh, you have a very different experience of the word good than I do. So let's be concrete about this one. So let's move from the generalities. We think in generalities, but we live in detail. I'm going to use an example that I have been using literally for decades. And I'm never going to tire of it, because apparently the world is never tired of getting it wrong. I want to take you back a few months. EA, as in EA Games. Have you heard of EA Games, small games company? Yeah. Right, okay, so here we are on Twitter. We are aware of an issue on console in which the game may crash on startup. Wow, that's not good. This is currently being investigated and will be fixed as soon as possible. Okay. We need a bit more context than this. Let me give you some context. February the 29th. For those of you watching in Videoland, it's 2024. Guidance for PlayStation players. On your console, go to Settings, System, Date, Time, Set Date and Time. Set manually. Change the date to the 1st of March. Apparently, it came as a surprise to Apparently the folks at EA don't know that once every 4 years, typically we have an extra day. Yeah? Just like the people at Microsoft who named the product Microsoft 365 rather than Microsoft 365.255. So this is, I will never tire of the leap year example. But the funny thing is most people get it wrong at a different level. Most people don't get it this wrong. So, I mean, applause for EA, well played, for getting it as more wrong than most people in the year 2024, when you kind of think this is a done thing. No, I will stop using this example when people stop screwing it up, okay? So, that's a challenge. So let's talk about time. Let's talk about this thing. So, I'm going to do this first example in Java. I think the tags, all of this talk was put together, the entry on the web page was put together this morning. There's a tag there that says JavaScript. You will see no JavaScript in this talk, okay? I did not use ChatGPT to translate the examples or anything like that. This is Java and C# this talk. Yeah, everything I say can be taken in principle and used in JavaScript. I've done this stuff in Jest. It can be used in Ruby. I've done it in RSpec. And you can do it in Python. I do this quite a lot in PyTest. All of the principles are translatable, but I need something concrete, okay? And I'm going to use JUnit in this particular example. So what we've got is the usual Java noise, public static Boolean, is leap year in year. Okay, there's a truth we wish to determine, true or false. Okay, great. So let's start our testing journey. Yeah? So we start out. Somebody says, oh, yeah, I'm going to write a test. What are you going to call it? Well, test. And all the code's going to be in this one place. Yeah? Don't laugh until you see it. Okay? You see these monolithic tests. Proper monoliths, not the kind of things people are talking about in terms of microservices. I mean, actually, a big slab of stone that is actually hard to move. Now, it might be testing correctly. I'm not challenging the correctness of this. This is an important idea. We're not challenging whether or not the test itself is correct. We're challenging whether or not we know and can understand the test, because the test is code. Your test base is made of code. That means that somebody has to read it and understand it. Your challenge is not to satisfy the compiler and the testing framework. Your challenge is so that future you and others can go, yeah, I see what you're doing here, and can extend, maintain, correct, or whatever. Okay? Test is not going to cut it. Oh, okay, now we're being specific. Wow. Look at us using more words. But it's still all in one place. We've just given it a better label. But the funny thing is what people then do with this. Sometimes they go, oh, you need more details. Okay. Test is leap year is okay. I said there's a really common set of smells, and don't feel bad if you've done these, because we often get drawn towards it. You're trying to say something. What is it I'm trying to say? Oh, it's okay. Or is correct. That makes it sound more formal. Okay is a little bit chatty and conversational. Is correct. Makes me sound like I do computer science. Works. That sounds well-grounded. It's just like, yeah, I'm an engineer. Works as expected. Yeah. You see, the problem here is there might be somebody at EA going, well, it worked as I expected. The problem here is not whether or not it works as you expect. The problem here is your test is not merely an act of verification. A test is an act of communication. The goal here, the challenge, to be precise, as it is with all code, is not does it work, but what do you mean by it works? That's the challenge. What do I understand as works as expected? So this is not going to cut it, even if technically the assertions are all good. So you tell somebody to divide up tests. This is also a popular technique. I have seen this one in companies. Because somebody says, oh, yeah, you've got all your tests in one place. Okay, we'll split it up. There you go. Yeah, actually, this is possibly worse. Because now things are scattered arbitrarily. Where shall I look? Flip a coin. Well, for those of you that still have coins, I discovered the other week that actually that's not a thing we have in the house anymore, except underneath the sofa or something like that. So, but the point here is that it's arbitrary, and arbitrariness is the worst thing that we can have if we intend to understand something. You're actually better off putting it all in the same place. Yeah? Okay, now we're getting somewhere. We're starting to use the language of the problem, the language of the domain. We have leap years and non-leap years. Now, formally, if you wish to really talk about this, you would talk about common years as being non-leap years. I'm just going to use the simple opposites here, so leap years and non-leap years. So this seems to be an improvement. And we can throw in some examples. So this year was a leap year. So was 2000. However, the problem that we have here is that although these statements are true, 2000 was a leap year for a very different reason than 2024 is a leap year. They are not leap years for the same reason. Now, if you're not sure what I'm talking about, just wait a couple of minutes, all will be revealed. If you do know what I'm talking about, you go, yeah. They are both leap years, but for different reasons. So, in other words, this is not quite telling me everything that I truly understand. We might decide, okay, we're going to subdivide this further. So here's another test smell. You start embedding all of the test data in the name. Now, the point is that we've now got 4 tests. So we've actually got the right number of separated names, if you like, for this problem domain. The problem is we still don't know why. 2024 is a leap year, but for a very different reason to 2000. 2023 was not a leap year, but it was not a leap year for a different reason than 1900 was not a leap year. But we haven't communicated that. We've just thrown you a bunch of numbers. If you did not know what the rule for a leap year is before reading this, you still don't know after reading this. I haven't communicated anything useful. And more importantly, I have not communicated my intention here. These numbers are examples of data, but they are not significant in the domain. Yeah? If I do this, the advice I gave to future developers is look to the past. I've been using this example for years. So we can go back to 2012, and I was using this example, and I would have put 2012 rather than 2024. But the point there is the number, that's not important. So, in the 97 Things Every Programmer Should Know book, which was published a number of years ago, also by coincidence, 73 contributors, there was a nice piece from Jerome Saros, write tests for people. That's your target audience. You're not writing tests for the build system. You're not writing tests for your company process. Have they written tests? Yes. Okay, we're doing well. You're not doing it for that. You are writing it for other people. This is a social concept. This is a communication concept. Gerard wrote this enormous book, X-Unit Test Patterns, basically unit testing patterns. It's about 900 pages thick. You can use it as a weapon. Okay? If you cannot convince your colleagues through the wisdom of your ideas and the ideas contained in the book, just use brute force. You will write tests like this. But what's the real message here? Who should you be writing the tests for? You should be writing the tests for the person trying to understand your code, specifically for the person trying to understand your production code. You're not writing your test code for the people who want to understand the test code. You're writing your test code for the people who want to understand what is it that the production code does or should do. Good tests act as documentation for the code they are testing. They may not be the only documentation, but that is part of their role, communication. So, let's understand this. How might I write this on a whiteboard? Here is effectively a first draft of the rule. A year divisible by 4 is a leap year. Yeah, that's the way we normally think about it. That's this year. A year divisible by 400 is a leap year. That's interesting. If you didn't know that one, that explains 2000. But you might be going, wait a minute. 2000 is already divisible by 4. That is true. A year not divisible by 4 is not a leap year. That explains why last year was not a leap year. A year divisible by 100 is not a leap year. Okay. This is the Gregorian leap year rule. Originally introduced at the end of the 16th century and then slowly rolled out until the early 20th century. It's a very slow rollout. Okay? And the point here is this is what makes the rule interesting. It's a rule that has an exception that itself has a further exception. Yeah? That's too much for the human stack. That's why most people don't know the full rule. And that's why I use this example. It's not that the code is hard. The code is not hard. It's the statement and understanding of the problem. Okay? If you randomly wander the streets of Budapest and you find a stranger and you go, what is the Gregorian leap year rule? That stranger will tell you in no uncertain terms, and probably in Hungarian, go away, you weirdo. But for those few people who do know, they would normally say once every 4 years. Amongst developers, I've been using this example, as I say, for many, many years. I would say between 5 to 10% of developers know the full leap year rule. That's why it's so interesting. Again, it's not the implementation, it's the understanding of the nature of the rule. If you can do the leap year problem, that is half of the kinds of tests you ever need to worry about in terms of businesses and the weird rules that businesses have. Okay, so here's our starting point. I'm going to turn this into code. Amazing, I just put underscores in there. That's fantastic. I've just turned words into code. And I did it without ChatGPT. So, this is our starting point. Now, there's a few things we can do to improve this. One of them is a very simple observation that I'm going to reorder this. And notice, although I've said I'm doing this in Java, I am breaking with Java conventions. And by the way, I do exactly the same thing in .NET. I am breaking with .NET conventions. I am not using camel case or Pascal case here, because this stuff does not scale beyond about 30 characters. And these names are going to be long. I want people to be able to read them. I don't want people to have to look for the capital letters. Okay? The point here is that this is a very different kind of thing. I break the style intentionally, not because I don't like the style, but because this is a different context. Although I am using naming, I am not naming ordinary methods. These are not ordinary methods. They do not get called anywhere else explicitly. These are not ordinary classes. They have a very different role. It's just like you can use a language. So let me just pick on English for a moment. I can use English to write messages. I can use English to write emails. I can use English to write shopping lists. It turns out that although I'm using the same language, I use different conventions in each context. Test code is a different context to production code, so therefore I will follow different conventions. And importantly, there's no other Java code. These are never going to be called except by the unit testing framework, JUnit in this case. Okay, so I'm going to reorder these. A thing to think, always remember, whenever you are writing tests, the order in which you write them is not necessarily the best order for reading them. Yeah? The order in which the ideas occur to you might not be the best way for somebody else to be introduced to the idea. So always go back and look at that. And remember that one of the things that you're doing when you are writing your tests, whatever workflow you're using, you are learning to talk about the thing that you are building. These names are not permanent. Okay? Always come back and revise them based on your understanding. Your understanding will change as you go from the top of the file to the bottom. And you will realize, oh yeah, now I really understand it in a way I didn't when I started writing this. So think of them as very temporary. Okay, the next thing I'm going to notice here, so I've gone from, the ordering that I have chosen is I have chosen the most common to the least. Years not divisible by 4, that's the largest category, and so my narrative ordering is, that's the most years, this is the next most years, years divisible by 4, then years divisible by 100, then years divisible by 400. I go from the most common to the least common. There are other orderings that also make sense, okay? Just choose a consistent ordering, okay? Sometimes people will lead with, here are the exception cases. Sometimes people put the exception cases at the end. Whatever it is, pick an ordering or discover the ordering that you want to communicate in. Yeah, it's yours to figure out. But we also have an interesting thing going on here. We have some contradictions. So one of the key guidances, one of the key smells that we end up with is test names that contradict each other. Test names should not contradict. They should be mutually exclusive. What do I mean by that? A year divisible by 4 is a leap year. That is stated as a truth. A year divisible by 100 is not a leap year. That is stated as a truth. These two cannot simultaneously be true. All numbers divisible by 100 are divisible by 4. They cannot both be leap years and not leap years at the same time. So what I really mean, and this is how you learn, you clarify. Oh, okay. Yeah, we're going to run out of space. Okay. A year divisible by 4 but not by 100 is a leap year. Ah, that is true. And a year divisible by 100 but not by 400 is not a leap year. Ah, okay. So therefore you discover, as you're writing, you look for the contradictions and things. Look at this as a learning exercise. You're sketching things out, trying to find the meaning, and being more precise than normally human beings are. We work a lot on implied meaning here. So we've moved from a model where we might have naively thought of, here's all the years. There are years that are not leap years and years that are leap years. We have a much more refined model now. This is the shape of the domain in terms of its values. This is how I tend to think about it. Okay? There are 4 kinds of year, not 2 kinds of year. Okay, so we're doing really well here. Now, there are other variations of naming style. You've got this kind of Osheroff style. He uses this in the art of unit testing. Basically, the unit of work, in this case a method, is leap year. The calling condition, year divisible by 4 but not by 100, and then the result returns true. So you can use that style. There's a kind of BDD kind of style. You can go and find Dan Tilhurst North and blame him for this. He's around. Where you use the word should. If this helps you, absolutely go for it. I tend to find that should is a noise word, and it also, you can see it's extra noise. Does it add any meaning? No. Does it make us question what we're doing? No. So I don't tend to use it because it doesn't sound very clear. Some people double down on this and go, yeah, must. It's still a noise word, okay? But if this works for you, absolutely do it. I prefer this style. There, by the way, are a few other styles, but what I want to characterize about all of these, what is common to all of them, is they all contain the same information. They are all saying the same thing. None of them are saying test one. None of them are saying, oh, just test leap years and non-leap years. Each one of them contains the same information, but it chooses a different style to present it. Whichever one of these works for you, you go for it, because you've already solved the main test smell problem. But I use this style, the propositional style. The propositional style basically is based on logic. And this is the book that I learned logic from, which, if you look at it, you realize that that makes me quite old, because book covers don't look like this anymore. Propositions are vehicles for stating how things are or might be. Thus, only indicative sentences, which it makes sense to think of as being true or being false, are capable of expressing propositions. The sun is shining. That is a true statement at this point. Okay? So what we've got here is statements of truth. This terminology, propositional and indicative sentences, you can find in a few places. In fact, I use this example so much that JUnit 5 actually uses the leap year example and talks about indicative sentences or statements. So let's have a look at a very simple implementation of this. Basically, one statement. This one, when I present this code to these tests, they pass. All nice and green. The naming tells you, gives you a sense of confidence of what you might have. It doesn't guarantee that your code works. Always remember, if a test passes, it doesn't mean that the code works. It gives you confidence that it works. It could still have bugs, but the idea is that we have some confidence that these statements are true of our code. But what is more interesting is when I substitute the Julian leap year calculation, the one that everybody still holds, in spite of the fact it was updated in the 16th century, every 4 years. Oh, sorry, when I said everybody, I mean everybody except EA Games. They are pre-Roman. They have not yet worked out their leap years. When I substitute this code, then what I get is red. For those of you watching in colorblindness, that's the third one down. I say that as a colorblind person. I'm realizing that my distinction between colors is not as strong. I just happen to know what the answer is. Now, what is interesting here is that this one tells you this is a property of a good unit test. If a test fails, then it means that there is a problem in your code. But what is the problem? I have said a year divisible by 100 but not by 400 is not a leap year. What is the problem? The problem is that a year divisible by 100 but not by 400 is a leap year. In other words, I know exactly what the problem is. The name tells me. It's the negation of the name. It's not whatever the name claimed. Okay? I know what's wrong. That's why I don't like the should and the must and all the rest of it. This is a statement of what I can now work out what I don't have. I might not know why I don't have it, but at least I know versus, say, test 3. Test 3. Test 3 failed. What does that mean? I have no idea. What does it mean when it passes? I have no idea. Now I have knowledge. I have communication. Okay, so we got that. Now, there's an observation that Marit van Dijk makes in one of the pieces in 97 Things Every Java Program Should Know. You can find it on Medium. A failing test should tell you exactly what is wrong quickly, without you having to spend a lot of time analyzing the failure. This means, okay, and this is kind of an interesting and important consideration, each test should test one thing. When we say one thing, it doesn't mean it has one assertion, it tests one idea. That may take more than one assertion to express. It's one logical assertion, if you like. It's one idea. That's what we're trying to focus on. Use meaningful descriptive names. Yeah, we need to be a little more, we need to be a bit clearer than that, because the word meaningful is not helpful. You remember test 1 and test 2? Those were meaningful names. What did they mean? Test 1 was the first test I wrote, and test 2 was the second one. That's literally what they mean. So the word meaningful is not helpful. If you ever end up in a conversation about meaningful names in code, stop yourself and go, yeah, it probably does mean something. It's just not what we intended it to mean. Descriptive, yes, but as Maria says, don't just describe what the test does either. We can read the code. Tell us why. We want to capture intention and purpose. This can help decide whether a test should be updated in line with changed functionality or whether an actual failure that should be fixed has been found. That's quite important. We've all experienced this, where, you know, if you're using a test-first workflow, I'm expecting the next test to fail because I've just written a test for functionality that does not yet exist. I'm expecting that. That's good. I was expecting red. On the other hand, if I've just done a whole load of updates and I've adjusted a couple of tests and something fails, and I go, oh, yes, I forgot to update that test in line with the new functionality. That's just you being human. On the other hand, it could also mean that something unexpected, that's just software being software. In other words, oh, we didn't expect that. Why is that broken when this was changed? Now you have an investigation on your hands, okay? So the idea is that's what we want, is the communication is one of the most powerful ideas. That's what we mean by good. And never trust a test you haven't seen fail, which is one of the reasons why any workflow that encourages you to do a failing test first makes sure that the thing that should not currently work does not work. I'm sure we've all had the experience of writing tests that apparently all work, and we discover either we've copy and pasted, or we forgot to put @test in front of things, or whatever. And then when we actually do that, we have a rude awakening. OK, are we done? No, of course we're not. There's more. There is a display name generator, and that you can use in JUnit. Replace underscores, and that also works with this testing style rather nicely. It means that on the output, it will actually remove the underscores and replace them with spaces. Awesome. So now you end up with proper sentences. But notice something else here. I have now shifted the whole language and structure. I am now using nesting. The nesting captures commonality. From my point of view, let's go back to where we started. There are leap years and non-leap years. I still want to say that, but now I'm going to give you the reason. A year is a leap year if it is divisible by 4, but not by 100. A year is a leap year if it is divisible by 400. OK, that's kind of nice. So now what I've done, and this is a common way to react. You may discover this as you're going through your tests and writing them. You may say, well, you know, I know I'm expecting long names, but some of these names really are very long. The thing to notice is that they are not arbitrarily long. They will repeat themselves. There are whole points between, oh, these 3 tests have exactly the same opening sentence or exactly the same closing part. That's not a coincidence. What do we do with commonality? We extract it. We show the reader. Guess what? It's not a coincidence. So we use nesting and other structures to do this. And most testing frameworks will support this kind of idea. Even classic JUnit 4. When I'm working in Python, I do exactly this. I use classes as a nesting construct. And you can nest classes within classes and so on. Use the structures of the language to express this. Now, some testing frameworks actually properly step outside the whole kind of concept of classes or modules or whatever and say, no, we have a different approach. If you're working in Jest or something like that, you're already familiar with this idea. You don't have to fake up underscore-based test names. You've actually got proper sentences, and you can nest describes within one another. So there's a lot that you can use. So there is this observation from Nat Price and Steve Freeman, who basically kind of helped originate the idea of mock objects. In a session they ran at a conference a number of years ago, are your tests really driving your development? They observed, for tests to drive development, they must do more than just test that code performs its required functionality. They must clearly express the required functionality to the reader. That idea of communication comes back again. That is, they must be clear specifications of the required functionality. That's a really important idea, and we see that in the name leap year spec. I've shifted from calling it leap year tests, or is leap year test, or whatever. Spec is a term you may have come across if you've looked at it from the BDD perspective. But that idea is a very powerful one. OK, now we've got some example stuff here. Let's look inside the test. If it is not divisible by 4, assert false is leap year 2023, assert false is leap year 1900. Well, I'm only using one example in each case. Sometimes we want to use multiple examples. How do we do that? Well, we could do it like this. I'm going to suggest that this is not the best way of doing it. Sometimes you have to do it this way because of limitations in a testing framework, but the best options that we have are when we're able to step outside that and go, you know what? We can parameterize our tests. We can make our tests data-driven. And that allows us to understand that so basically this test method will now be executed 4 times, once with 2023, once with 2022, once with 1999, once with 3. Now what I can do is I can use examples. I can use examples that are familiar to the reader. Okay, 3 does not look like a year, but it is a year, but it's a nice simple example. But the others are familiar. So use data or values that are familiar to the reader or belong in the domain. Don't use foo and bar. For years, don't use 1, 2, and 3, and that's it. Use things that look and feel like years, okay? But the point is I'm not paying any extra penalty for this. I can increase the parameterization just, yeah. In fact, this is quite a good technique for productivity because it shows up, you know. Let me just show you. Oh yeah, you write this. How many tests passed? 1. You see it on the output. Test run 1. You run this 4. Your productivity is awesome. Okay? Yeah? Don't say I don't help you. Okay, so the point here is it's easy to scale this one up. And it shows us there are 3 aspects of the test. There is the intention of the test, which is captured in its name and its nesting. This is what this test is about. This is what we're trying to say. This is what we're trying to achieve. There is an example. Let me show you how the code works. And then there are, an example of the code. And then there's an example of the values. So that's 3 aspects, and we've separated them out here. Modern testing, if you're using a testing framework, I mean, it's 2024 now. If you are using a testing framework that does not support parameterization, that is called legacy code. You have legacy tests. I'm kind of hardline on this now. It's the 2020s. Any testing framework that does not support parameterization is not worth your attention, okay? Okay, and I can do that for the whole lot. This is great. Okay, there's still more. Let's understand the way that we might look at our tests. We want to use, let's look at the example values and the cases. There are common cases. There are simple cases. There are boundary cases. This is a Venn diagram, okay? So some boundary cases will be simple, and so on. So we're looking at the overlap. You want to make sure that your tests have representatives of all of these. And then there are error cases. Just for the record, this is the correct way to draw a 4-set Venn diagram. If you type in 4-set Venn diagram on Google, it will give you lots of wrong answers, and that's without the AI. Yeah? 4 circles that overlap, no, that's not correct. This is the correct way to do it. Yeah, I call this the tulip of coverage because it does look like a flower. And of course, there's overlap. But what about our error cases? Do we have any error cases? Well, no, not at the moment. So let's be very artificial about this and focus on the idea of error cases. No, not a good name. A year is not supported. Oh, yeah. So a year is not supported. A year is illegal. A year throws an exception. Words like that. Be more specific. Now, I'm going to make one thing we haven't actually asked is what is the calendar system that we're using here? I've kind of implied it's Gregorian. A lot of people think that we work with a Gregorian calendar. In fact, I was setting up a new Windows machine the other week, and Microsoft thinks that we use a Gregorian calendar. This is not correct. We don't actually use a Gregorian calendar. The calendar that most countries use is ISO 8601. So, you learned something else today. And ISO 860, I'm not going to conform to ISO 8601, but the idea is obviously it's congruent with a Gregorian calendar, but it's not the same. But legally, most countries use ISO 8601. The web uses ISO 8601. So most people in the world use ISO 8601 without even knowing that they're using it. That's amazing. Why does this matter? Well, I'm going to create a calendar for this problem. I'm just going to say I'm not going to worry about the fact that different countries change to a Gregorian system at different times or an ISO 8601 system at different times. I'm going to say, for our example, we are dealing with a common era proleptic Gregorian calendar. Let me translate that into slightly simpler English. Common era, year 1 onwards. Proleptic, backdated. It's as if it's always been there. Gregorian, it's always had the same rule. Okay. Given that, a year is not supported if it is 0. Assert throws, a legal argument exception. A year is not supported if it is negative. And I'm going to separate out the 0 and the negative cases, not for reasons of coverage. I could very easily just roll the 0 into this and just say if it is not positive. The reason I put in the year 0 in a separate case is very simple. Because a lot of people have a debate about whether or not there is a year 0. I've done this in a classroom where the classroom spent 10 minutes discussing whether there was a year 0 or not. That tells you that this is an interesting topic. Therefore, I separate this out as a separate test, not for correctness or coverage, but for emphasis. Just as if you are writing an email and you want somebody to notice something, you put it in bold or you put it in its own paragraph. You're basically saying, look at this. You're not going to fold it into something else. You're going to say, look at this. I want you to notice that we have accounted for this case. And by the way, the answer to the question, does the calendar have a year 0, is obviously it depends. Some people will very much tell you, I had an argument with JB Rainsberg about this a few years ago, and I said, actually, JB, you're wrong, because ISO 8601 does have a year 0, and that's the calendar that you use. So just so you know. Anyway, I'm not trying to get you to pick fights with people over calendars. But it's not a bad cause to have if you're going to argue with people. It's much cleaner than politics. Yeah. Okay, but also, if I'm saying negative, how well am I backing up my claim? Previously, I was just going down to minus 400. You know what? Just go all the way. The min value. I don't care what it is. It's just not supported. That also inspires me to say, wait a minute, we haven't actually ever explicitly said what is supported. So here, I'm basically going to say, yeah, we're supporting positive values. I'm not going to test whether or not they're leap years or not. I'm just going to say, these do not throw. And I'm going to make that explicit. This is documentation. 1 and the max value. We're good. So, we've dealt with the error cases, and now we've got a nice specification. Leap year spec, a year is a leap year is not a leap year, a year is supported if it is positive, a year is not supported if it is. This is really nice specification-wise. Now, we are approaching lunch, and I'm going to help you avoid the queues. We're going to spend just a couple of minutes. I've got the second examples very quick. We're going to get our ducks in a row. It's a queue. To understand a queue, we have a producer, a consumer. Whatever queue you're dealing with, there's always a decoupling. There is an action. We enqueue, the data flows this way, the control flows this way. You dequeue from the consumer. In this particular model, you enqueue onto a queue. It has a capacity. How many things can you put in the queue before it fills up? After which you're no longer allowed to put anything in. And therefore, it has a length that goes between 0 and the capacity. So that's the conceptual model. Now, I'm going to do this one in C#, which for those of you watching in Java is just change the case on a few things. It's pretty similar. We construct with a capacity. We can find out the capacity as a property. We can find out the length as a property. We can enqueue, and enqueue may or may not be successful. But we're not treating it as an error condition if it's not, because it's natural for queues to fill up. You can't enqueue on a full queue. Likewise, we can always dequeue. If it's empty, you get nothing. Okay? So we've got a nice little symmetry there. The temptation, let's go back to Nat and Steve's observation, tests that are not written with their role specifications in mind can be very confusing to read. The difficulty in understanding what they are testing can greatly reduce the velocity at which a code base can be changed. So let's do the initial test smells. This is what everybody initially writes, and in fact, I still see it in a lot of code bases. I've got a constructor, so I'm going to test it. I've got a capacity property, so I'm going to test it. I've got a length property, so I'm going to test it. I've got an enqueue operation, so I'm going to test it. I've got a The problem is that to test dequeue, you need to also use enqueue. To test enqueue, you also need to know about length and capacity. In other words, these are actually tightly coupled to each other, and this name is actually not much better than test 1, test 2, test 3. The tests will look uncohesive. They won't be testing one thing. Also, by the way, they're just saying test, which is a repetition, so don't repeat yourself. So let's get rid of that. So sometimes people kind of say, okay, well, I'm just going to put some extra words in. So let me show you another smell that I see a lot. Oh, yeah, you're not supposed to say test constructor. I'm going to say can be constructed. See what I did there? I added more words and made it look like I'm doing something sensible, like using proper sentences. Has capacity, has length, can be enqueued on, can be dequeued from. See, my use of more words clearly makes it better. Except you may also start recognizing that these are not true. Because you can't always enqueue. What if it's full? Then you can't enqueue on it. And you can't dequeue from an empty queue, so you can't always, oh, okay. Can sometimes be constructed, but can sometimes be enqueued on, because you can't have a negative capacity, or is that? Yeah, this is, okay, I'm going to quote Venkat Subramanian here. A good test should tell us a short story, not drag us through a murder mystery. Right, let's use nesting. I can use namespaces or classes in NUnit. And here I've got something that is a little clearer. Queue spec. Creating a queue leaves it empty. Creating a queue preserves positive bounding capacity. Creating a queue fails with non-positive bounding capacity. Oh, okay. Now you're telling me this is a specification. Enqueuing on an empty queue makes it longer. Enqueuing on a full queue is ignored. Okay, this reads like a specification. This is pretty good. There's a little refinement that we're also going to make here. And the refinement is I'm going to pick up on an observation that let's think about the conceptual model of a queue. We might initially think of it as being empty and non-empty, which is reasonable. We can create an empty queue if the capacity is greater than 0. When we enqueue on an empty queue, it becomes non-empty. Okay? When we dequeue from a non-empty queue with a length of 1, it becomes empty. When we dequeue from a non-empty queue with a length greater than 1, it remains non-empty, just shorter. So this looks like we're moving in the right direction. It's giving us some of the language of the domain that we want. But actually, it's more complex. Because when it's not empty, it can either be non-full or full, and it behaves differently. And that's much. Now, what I want you to notice, so I'm not going to teach you state chart notation at this point. I want you to notice the kind of the concept, the transitions and the structure, and the nesting. There's another way of writing those tests. Previously, those tests were based around constructing, enqueuing, dequeuing. I'm going to reframe those tests based on that model. I'm going to use a state-centric approach. In other words, I'm going to talk about a new queue, an empty queue, a non-empty queue that is not full, there's the nesting of the states, a non-empty queue that is full. There's a direct correspondence between all of the transitions and all of the states on that model to my tests. And I feel so these tests are, by the way, just for the record, they are identical to the tests that I showed you before. They've just got different names. If I showed you the bodies would be identical. I've just moved them around. But I've shifted the emphasis from I'm going to focus on enqueuing and dequeuing to I'm going to focus on whether it's full or not full. So I structure it differently. Now, you may have come across the given when then advice to structure the internal structure of a test. Arrange, act, assert. These are equivalent. But I want to take this further. You can use given to group things with common state and common setup. I can also use when to group things with common state and common setup. That was the first example that I showed you for the queue. Effective, I didn't use the word when, but when in queuing, I'm going to show you what happens. When dequeuing, I'm going to show you what happens. Whereas I then refined it, I think this is a better way of doing it. It's not more correct or less correct. I think it just communicates more. But you may differ, and that's what you've got to discover. So I've shifted the emphasis. I want the reader to see the state model rather than the actions. In other cases, I do exactly the opposite. I say, oh, this is about the actions, and I want to show you how this action works in different states. And I want to emphasize that. And of course, if I can use it with given and when, I can use it with then. And you may say, well, why would I do that with a queue? Then it becomes empty. That I don't. We just did it with the leap year example. Then it is a leap year. Then it is not a leap year. Then it is supported. Then it is not supported. So if you're already familiar with given, when, then, this is your guru option. It's not just for the inside of a test case. It's actually for how you organize. You can use the same concepts for grouping and structuring. There's deeper relationships that you can use to communicate to your reader. So I hope that's been useful. And I presume now you're off to write some tests again and revisit them. Good. Catch you later. Thank you.
That's okay. One Slido question, and then I leave you for lunch.
Yeah, I am around, by the way, all day,
Yeah.
so you come and find me.
Okay, so one only. Some libraries can make test writing much easier, such as Instancio, but reading them will be much harder. What's your opinion on using such libraries?
If something makes reading harder, then I think that's a problem to be solved, rather than a technique to be encouraged.
Okay, that's enough. And just a little pun that when you are reading unit test, you have a gut feeling.
Oh, yeah.
Okay.
No, you didn't need to say that. Right. Okay. I'll see you all over lunch.
I have.